Hello. In this video, I would like to provide a brief note on free electron theory. Let's come to the point. The free electron theory of metals aims to explain the structure and properties of solids through their electronic structure. The electron theory is applicable to all solids that may be metal or non-metal also. And this free electron theory supports to explain the electrical and thermal and also magnetic properties of solid. The theory has been developed in three main stages. That is, the first stage, the classical free electron theory, which is developed by Drude and Lorentz in 1900s. According to this theory, the metals containing free electrons which are obeys the laws of classical mechanics. And similarly, come to the stage 2, the quantum free electron theory. The Sommerfeld developed this theory in 1928. According to this theory also, the free electrons obey the all quantum laws, which is in micro states. And this classical free electron theory is in macro states. Now coming to the third stage, the band theory or zone theory. The band theory or zone theory, which are calling here, which is developed by Bloch. And Bloch stated this theory in 1928. According to this theory, the free electrons move in periodic field provided by the lattice. And this theory also called the band theory of solids, which is a crucial role in to find the structures of solids and the conductivity nature of the solids. From this band theory, the concept of hole, origin of band gaps or bands like valency band and conduction bands also, and effective mass of electrons or the special features of this theory or the metals. According to classical free electron theory, which is derived by Drude and Lorentz, the valency electrons are in any one atom. Here I consider the sodium atom. In this sodium atom there is a valence electron. This valence electron belongs to 3s, and these electrons are core electrons. And now this is nucleus. Now the free electrons move about the whole volume of the metal like the molecules of gas, perfect gas, in a container. And some of free electrons moves in random direction and collide with either positive ion fixed to the lattice, and all collisions are elastic in nature. That means there is no loss of energy. Now here in this diagram, these are the free electrons. When these atoms are combined in so many atoms, which is created the sodium atom in lattice form. Now these are the valence electrons which are revolving around the entire lattice structure. And this is the nucleus. Now the distance between the any two nucleuses is 3.7 angstroms in sodium atom in lattice. Now if you consider the metal, which is consisting the fixed ions. Now this red marks is indicating that these are the fixed ions, and these arrows which will give the small dotted is called as free electrons. Now these free electrons, each other it will be collide, and these free electrons in occasionally it will collide with the positive ions. Now this is the metal as a gas of your free electrons. Now these are the free electrons in a container, and it will randomly move and it will be collision with without loss and with the elastic nature. Now the moment of free electrons which are obeying the laws of classical kinetic theory of gases in this container, then its average velocity is root of 8 kt by m and root of 8 rt by pi m, where capital M is equal to m into Na. By substituting this value here, we are getting this value. Now and similarly, the Vrms, which is root mean square velocity of these electrons, then root of 3 kt by m, that is equal to root of 3 rt by m, where k we are substituting r by Na. Then mNa is equal to capital M that we substituted here. The most probable speed of these electrons Vm is equals to 2 root of 2 kt by m. Then and now here, while we are considering this is the most probable velocity, average velocity, and root mean square velocity. With the x-axis we are considering velocity, and number of electrons we considered in n. Then by gathering this in a graph for the Maxwell distribution, it will create in this slope. That means the maximum position will be most probable, and then it is slightly decreased from v most probable velocity to root mean square velocity. Here the electrons, when it is in moving in random direction in a container, then it has velocities in a metal which is obeying the classical Maxwell-Boltzmann distribution of velocities. And then when the electric field is applied to any metal, the free electrons are accelerated with a drift velocity in the direction opposite to the direction of applied electric field. Because of its higher potential to lower potential, some voltage will be erased, and here we are giving the drift velocity is in opposite to that. Under the influence of electric field, the electrons gets velocity is known as drift velocity. The applied force on electrons is F. Then actually the force which is existed on the electron is F is equal to E into the electric field E. But in general, from the nucleus, from the Newton's law, F is equal to ma. So by equating this force and this force, F is equals to, and here F is equal to E is equals to ma. Then A is equal to E by m. But in general, A is equal to, that is acceleration is equal to velocity by time. Then this velocity here, we are giving some external force. Due to that reason, the velocity is exerted. So that's why it is a drift velocity by time. And it is, we equated these two. A is equal to V by T. Then we substituted this and this one. Now, Vd, that is a drift velocity, is equal to E, m and tau. Where Vd is the drift velocity and capital E is the applied electric field, and me is the mass of electron, and tau is the relaxation time. Now to find the current density in the container, J is equals to Ne into Vd in general metals. Now J is equal to Ne, already we find out Vd, that is Vd is equal to E by me into tau. Then we substituted this Vd in here. Now Ne into E square E by me into tau. Now J is equal to Ne square tau by me into E. But general, J is equal to sigma E. Now this sigma is equating for this. That sigma is the electrical conductivity in a metal, that is Ne square tau by me. And conductivity, when it is in reciprocal, it will give rho, that is resistivity. Now 1 by sigma is equal to me by Ne square tau, that which is reciprocal. Now where me is the mass of electron, tau is the relaxation time, and n is the number of density, and E is the charge of electron. If an electron immediately after it makes a collision, one collision to the another collision, average time what it is taking is called tau, that is relaxation time. So the time, that is tau, called as collision time or the relaxation time. From the drift velocity we know that the drift velocity Vd is equal to E by me into tau, where the tau is the relaxation time. Now Vd is equal to E tau by me, capital E, where this E tau me is termed as the mobility of an electron, which is mu. Now mu is equals to this one, because Vd is equal to mu E, where the mu is equated by this term, then E tau by me. Then the relaxation time tau is equals to then me mu by E. So it is the relaxation time with in terms of mu, that is the mobility of an electron. The average distance the electron travels between the any two collisions or any two successive collisions is called as mean free path. That I will shown in this diagram. If you observe, in this metal conductor, that is a conductor, in that there is an electron is randomly, it is in collide with each other and it is in motion. Now this part, if I will make it as maximize, and here this is the copper atoms which is in the metallic form, that is in regular periodic arrangement. In that the electrons is moving in random direction. Now here to here it is the collision. Now the first collision when first collision when I considered here, the collision of in between these two atoms, that is here electron is moved for here electron. Now this electron is collide, then the distance traveled, the distance, what I said here, it is the average distance the electron travels between any two collisions. Now here to here it is one collision. When the electron is moved from here to here, then it starts to one collision. So now from in between these two, length lambda is the mean free path, because in this before this collision up to here it is moved, so that's why it is the mean free path. Lambda is equal to average velocity into tau. Now that formula, lambda is equal to average velocity and tau of the electron, therefore tau is equals to lambda by average velocity is equals to tau. Now we know that already previously we derived that conductivity sigma is equal to Ne square tau by Me, where in that tau substituted by this value. Now sigma is equal to Ne square by Me into tau is equal to where sigma lambda by average velocity that we substituted here, and lambda is equal to sigma Me average velocity by Ne square, that will gives the mean free path in terms of average velocity. Actually tau is equals to, according to the mobility of an electron, tau is equal to mu Me by E. Therefore where tau we will substitute this value, here it is lambda by average velocity, then it is in lambda is equal to average velocity is multiplied, here it is mu Me average velocity into E. Therefore mean free path in mobility terms is this.